Hey, Algebra 1, Mr. Catlin here with Lesson 24 Cooldown, helping you out with looking at solutions to systems of linear equations. So not just linear equation solutions, but now we're looking at systems of them. So we've got two lines on the graph, and both of the lines are created by having two variables in the equation, or the inequality in this case. And then there's going to be shaded regions on both sides. And we're looking for where those shaded regions overlap. And that's going to be our solution. So that's our general idea. Let's take a gander at what this one is. This one is just a riddle, just having a riddle with numbers that have to be bigger or less than certain things. So here's the riddle. The sum of two numbers is less than 2. If we subtract the second number from the first, the difference is greater than 1. What are the two numbers? So there's our riddle, and we need to break it down one step at a time. So let's go ahead and define our variables as x and y, because that's what our graph shows down here. And the sum of two numbers less than 2, that would look like this. Sum of two numbers is smaller than 2. If we subtract the second number, which is y, from the first, okay, so that would be x minus y, the difference is greater than 1. So that would be greater than 1. We're looking for two numbers that can satisfy both of these constraints. All right. And down here at the bottom, we have lines of each of these inequalities, both dotted because they're both less than and greater than. There's no or equal to situations. And our first job is to say which one is which. Okay. So to make that happen, what I'm going to do is I'm going to think of these as equations. So I'm going to think of it as x plus y equals 2 and x minus y equals 1. So what ordered pairs can make these things true? So the first thing that I like to look at are my x and y intercepts. And so this one has an x-intercept or y-intercept of 2. So that means when x is 0, y is 2. And that only works for the top one. So this ordered pair at 0, 2, x can go in for 0, 2 can go in for y, and it would make that one true. So this one right here must be x plus y equals 2. Actually, is less than 2, sorry, which is why they shaded below it, because it's less than. And then by process of elimination, that must mean that this one is x minus y is greater than 1. So x minus y is greater than 1. And let's test it out, see if it works. An ordered pair on this one, it looks like when x is 1, y is 0. 1 minus nothing is 1. So that makes sense. So this one right here is there. That ordered pair there at 1, 0 goes in and works for that particular pair of x and y. So we've got that labeled out. Which graph represents which inequality? Check. And then it says to name a possible solution to the riddle, because there are many solutions that could make this work, because it's not equal to, it is less than and greater than. So if it was equal to, this would be the solution that makes them both true, which looks like 1.5 and 1/2. That would equal to, and it also, when subtracted, would equal 1. But we just want to know the ones that make both of them true. Okay, so the first one, x plus y is less than 2, is everything blue shaded, and x minus y greater than 1 is everything that's kind of got this little diagonal sketching shaded. So the section of this that represents solutions that make them both work is where those two shaded regions overlap each other, which would be what I'm highlighting here in pink. Okay, so this section right here represents all of the possible solutions to the riddle. And so I'm just going to pick one that I know is there. If I go, let's see, let me grab my writing utensil here. Let's say that I go over 1 and down -1. Okay, that point, -1, comma 1, will make both of them true, right? So name a possible solution to the riddle. I'm going to say -1, 1, and explain or show how you know. And I'm going to show it over here. This ordered pair falls in the shaded region for both Emphasize the both, for both inequalities. And that's how I know it works for both of them, because it's in both of their shared shaded regions. There are many others. You could pick 1, -2, 2, -1, 2, -2, 3, -2. Oh, there's a lot of different ones that could work. This is just the one that I chose. This ordered paired falls in the shaded region for both. And so I know that it is a solution to both of these systems in the system. I hope this was helpful. We will continue working with these inequality cross sections of shaded regions as we move forward. We'll see you guys later.